Okay, this is Introduction to Statistics, Chapter 1. We're going to cover in Chapter 1 statistics, the basics of it, what parts and components are made of statistics, how are studies and surveys completed, and so forth. 1.1, an overview of statistics. So you'll see some of these notes have already been filled in. The computer crashed on me, so I'm just going to review what I've already done in the previous video, and we'll go from there. All right. So examples of statistics. Notably, 21% of 8 to 11-year-olds have a social media profile. Okay. That has some numbers in it, so we can clearly see that there are some statistics or some data that was collected and put together and then put out for everyone to be able to read. The Bible is the most shoplifted book. So this doesn't have any numbers in it, yet it's still a statistic. And we'll look into how that is as we go out through this section. All right, so first, data. Data is information coming from observations, counts, measurements, or responses. So these are the numbers, the words, or the terms that are collected. And then from there, we have statistics. So this is the science of collecting, organizing, analyzing, and interpreting data to make decisions. All right, I'm gonna pause, let you write that down. All right, hopefully you've unpaused by now. All right, so it's collecting, organizing, analyzing, and interpreting data to make decisions. All that is done in order to create a statistic. All right, data sets. The first one we have is population. So the population is a collection of all outcomes, responses, measurements, or counts that are of interest. Collection of all. That means we have every piece of information that we can have and we've collected it. When we're describing a data set, sometimes you will either see this or you'll put this as your answer. All right, the set of all or collection of all. So if I'm taking the set of all times it takes to drive to campus, the set of all times of college students it takes for them to drive to campus, or collection of all, meaning I have every piece of data from that school. Sample is a part of a population. So we don't have all the information. We may not even have access to all the information, but I can get some information. I can collect some information. All right, so a part of a population is called a sample. And this is what we mainly use in a lot of statistics, a sample. This is used to gain information about a population. So we use a sample to state that, okay, we ran these surveys or tests or, um, or whatever the studies, and we received this information from our sample. And we're going to say that we think our population has the same information. All right. So describing data sample sets consists of including other observations, and we'll look at that at the end of the section. All right. In the book, page 6 and 7, we have number 11, 1826. We're going to determine whether the data set is a population or a sample. Explain your reasoning. So number 11, the salary of each member at an advertisement firm. The salary of each member. So that means they went to everybody and received the salary. Meaning we can get all the data. So we can get all the data. They collected all the data. This is a population set. Population data set. Everyone was chosen. As opposed to number 18, the amount of money spent by every 10th person cashing out at a store. So I see that not everyone was collected, just every few. So every 10th person. That is why this is considered a sample. Okay. The next problem is kind of in the same vein, but just a little different. So this one wants us to identify the population and the sample. So with this one, we are going to see what population did it come from and then what's the actual sample. So sample normally comes with some type of number. So we should see some type of number tied to this. All right. A survey of 1,001 U.S. adults found that 47% of respondents typically feel well rested on Wednesdays. And we're going to mark out the describe the sample data set. Oh, yeah. No, sorry. Yeah, we do need this. This is number 32 in your book. Describe the sample data set. So this is how we're going to make that description. All right. So first, what is our population? Like, what are we pulling from? What are we pulling from? So survey of 1,001 U.S. adults. So this is how many they actually took, but where did this population come from? So the population is a set of, or the collection of, all U.S. adults. Put survey down here because it doesn't really specifically say what type of adult they're using. So it may say U.S. Adults who are parents. So you would put a set of U.S. adults who are parents. Now this is all they give us for this one. So the population is, where did they pick these people from? They looked at all U.S. adults, and then how many did they pick, or what did they pick? So the sample would be 1,001 U.S. adults. So when we're dealing with population and sample, we're looking at how many. We're looking at how many. So this 47%, that's actually a statistic. This is just telling us how many did we survey in this one. All right, and so what is the description? What is this stating? Okay, this is stating what is it? What was the outcome pretty much of this survey? So the outcome is 47% of respondents felt well rested. Well rested on weekdays. That's a description. That's what actually came out of the survey. Then we can also say, give the room, 53% did not feel well rested. Where do we get that from? Good, I heard you. Good. So if 47% of respondents felt well rested, then the opposite of that would be 53%, right? So we can make an observation of both what happened and what didn't happen. All right, so they're opposites. All right, two terms describe the numbers used in statistics. So remember, we're looking at that 47%. We're going to look at how do we describe that? So a parameter is a numerical description of a population characteristic. So that means we had data from the population, we calculated it, we crunched it, and we found that number, which is described as a parameter. A statistic is when we have a sample, a numerical description of a sample characteristic. So we look at what was that sample stating. So above 47%, this says describe a sample data set. That means that this was a statistic as opposed to a parameter. If this were to say all U.S. adults, then this would be a parameter. And we'll do a example of that very shortly. All right, sample statistics can differ, but population parameter is constant. So let's think about that. Sample statistics can differ, but population parameter is constant. So let's think about that. Why would that be? I hear you thinking. So the sample, it can vary because we're taking a group. So it depends on what group that you're talking about or that group that you've taken. That's why there is so much room for difference. I'll say that, room for difference. But population, it doesn't matter how many times I run those numbers, I'm going to get the same answers every single time. So that's why it's constant. So samples can have a little bit of wiggle room. It can be different, but population, it cannot. Okay. All right, let's look at some examples of parameters and statistics. It's page 7 in your book, number 36 and number 38, unless it's an updated edition. Determine whether the number describes a population parameter or a sample statistic. Explain your reasoning. All right, a survey. Okay, survey means normally they're taking some people. A survey of 919 College Board members found that 89% think that their institution is a good place for members of racial and ethnic minorities. All right, so we have to determine, are we working with a sample, a population, or a sample? So I don't know how many College Board members there are. It says that they surveyed 919. They didn't survey all of them. So I'm going to say that this is a sample data set. This is going to help me to determine whether it is a population parameter or a sample statistic. So now that I've identified this is a sample data set, I know that we are working with a statistic. So that means 89% describes the sample. So 89% is the statistic. If that's the case, do you remember what that 919 represents? Do you remember? Good, it's the sample. That's how many people were actually surveyed. Good. I'll say sample number. So let's do that, sample number. Next, in January 2021, 54% of the governors of the 50 states in the United States were Republican. All right, let's look at this. 54% of the governors. So it didn't say, let's say 54% of the governors. So it didn't say all the governors. But I do see that they didn't tell me how many of the governors were surveyed. So it means all of them were surveyed, right? All were surveyed. So for this one, all of them were surveyed. 50 states. So 50 states, 54% of them. So that means we have a parameter. And what is our parameter? What is that number or that statistic? And it's not always a percentage, but in these cases, they are a percentage. So 54% is the parameter. 50 is our population size, our population number. 50 states. It didn't say they took half of them or 20 of them or 30 of them. It says 54% of the governors. So that means they looked at all the governors. All right, so 50 were surveys. So that means that this is the population. Population number, I forgot again, it was 50. So all 50. right, last part. Descriptive and branches of statistics. So, what branches do statistics do we have? So, first branch is descriptive. This involves the organization, summarization, and display of data. So, you'll normally see your numbers here. You'll see numbers, or you'll see your data, the script described, or you'll see statistics. You see it in chart form, written out. You'll see some type of numbers or graphs. Anything that can give you information with numbers. Inferential statistics involves using a sample to draw conclusions about a population. So, with the inferential statistics, we actually sometimes we have numbers, sometimes we don't, but it's normally a generalization. Normally, generalization without numbers. I know that seems a little weird, so we're going to do this next one with inferential statistics. All right, so we've seen descriptive statistics with the 54% of the governors and the other percentages that we saw. Those are descriptive. We saw the numbers. Here, even this is descriptive statistics, and we're going to take it and infer it. All right, so what conclusion might be drawn using inferential statistics? A survey of 1,508 U.S. adults ages 40 to 64 found that 32% had provided regular support to their parents in the past year. So I'm looking at the statistic, and I'm trying to see out of the survey what happened, and then what can I conclude about all U.S. adults ages 40 to 64. All right, so I see a survey found that 32% have provided regular support to their parents in the past year. 32% isn't a large number. All right, so it's not 50, it's not half, and it's not over 50. So I'm not going to say that most adults, right, had provided regular care, because most adults that's not it's not even 40%. All right. So I'm going to conclude, just in general, just as inferential statistics. Most U.S. adults ages 40 to 64 did not provide. Now, if this is a higher percentage, it would be opposite, but it's not a higher percentage. So did not provide regular support to their parents in the past year. Basing that off of the sample. This is what the sample says. I think I picked a good sample, a good number of adults. And so I'm going to make a conclusion that most U.S. adults did not have that characteristic that I was looking for. Okay. So even if you do a survey or a study and it doesn't come out to be what you hoped it would be, it's still a good description or a good inference that can be made from that. Okay. Until next time. All problems and images are taken from Elementary Statistics, Picture in the World, Larson Farber.